Assalamualaikum warahmatullahi wabarakatuh. First of all, we would like to thank our lecturers for giving us this opportunity to accomplish our project. Our groups will present about smart home project. Before we dive into the details, let me introduce the members of our team. I'm Ku Aswad Adnan. Our team members are Ahmad Kamal Yaakob, Muhammad Nazri Abu, Jafrul Izwan Jaafar, Muhammad Afani Kadir. Together, we have worked collaboratively on bringing smart home solution to life. What is smart home? A smart home integrates technology to provide both convenience and security for homeowners. A smart home is the linchpin of keeping your home safe. This system can be set up as a wireless or hardwire system depending on the installation. Smart home technology provides homeowners with convenience and cost savings. Smart home technology plays a critical role in enhancing home safety, monitoring the home for potential intrusions, detecting water leak, identifying fire or deadly gases like carbon monoxide, and managing environmental conditions such as light, temperature, and humidity. In short, smart home automate a wide variety of tasks, making daily life more efficient and secure. To give you a better idea of how this system works in practice, we have prepared a short video that demonstrates the functionality of our smart home system. Now, let's get into the specific of the projects we have worked on. Motion sensor. The motion sensor is designed to detect movement. When it identifies someone approaching within this range, it triggers an action. This kind of technology is incredibly useful for automating entry points in homes, offering both convenience and security. Next, we have the humidity sensor. The sensor plays a critical role in managing the internal environment of a house. When the sensor detects that the temperature rise, it automatically switches on a fan, ensuring that the room stay cool and comfortable. Lastly, the light sensor is programmed to detect change in ambient light. When the sensor identifies a certain level of darkness, it triggers the light to turn on. Each of these sensors operate independently, but together they create an integrated system that enhances both comfort and security in the home. Now, I will pass to my team member to continue the presentation. Thank you.
Assalamualaikum and greetings guys. My name is Muhammad Afandi bin Kadir. My metric number is TA22003. So I will show you the component that we use for this project. First is a Node MCU ESP32 version 2. This is a microcontroller. It's a central brain of the smart home for this project. So the microcontroller processes data from the sensors, which is the input, and the controls output devices, enabling automations. Okay, for second is the sensors, which is the input. There are three types of sensor we are using. First is ultrasonic sensors, HCSR04, which we use for the non-contact distance measurements. These sensors measure the distance to an object using a sound wave. Used in automatic. This is used for automatic doors, security system, or object detection. Second sensor we are using is a temperature and humidity sensor, which is a DHT11. It is a measure environmental condition like a temperature and humidity. It is useful in a climate control system like smart thermostats. This sensor also factory calibrated and hence easy to interface with any microcontrollers like Arduino, and also for ESP, like we're using ESP32. Third sensor we are using is LDR, a light dependent resistor sensors, which is detect light intensity in a room, commonly used for automatic lighting system adjusting brightness based on the amount of natural lights. Okay, for output we are using LEDs, which is light emitting diodes. These LEDs convert electrical energy directly into light. This light used as our indicator output replacement. Also, we are using for output is active buzzer. This component that generates sounds through the transmissions of electrical signals. Its primary function is to provide an audible alerts or notification, and typically operates within a voltage range of about 5 volts to 12 volts. Also, we are using for output is a DC motor mini fan. DC motor mini fan is an electrical motor that we use a direct current DCs to produce a mechanical force, like a fan. Connected to the system, we are connected to the system to provide a ventilation or temperature regulation based on the sensor data. Also, we are using a component to support this project is the breadboard. The breadboard is used for construction base, the platform used to build a semi-permanent prototype of electronic circuits like this project. And also we are using a jumper wire like this. Okay, this is jumper wire is used for connect to 2 points, which we connect like the sensor to the controller inside the breadboard. And so also we use this one for support for connection. Okay, that's all, folks. Thank you for your attention. I pass to my colleague to continue the presentation project. Thank you.
Assalamualaikum. My name is Jafrul Izwan bin Jaafar, TA 22012, presenting on the cost for our project. So the grand total of the cost of the project is 57 ringgit, where we bought the Node MCU board ESP32 for 18 ringgit, breadboard for 2 ringgit 70 cent, 3 jumper wire 2 ringgit each for the total of 6 ringgit, 5 VDC ultrasonic sensor 3 ringgit 50 cent, active buzzer 70 cent, DHT11 sensor 24 ringgit 50 cent, light dependent sensor for 40 cent, DC motor mini fan 80 cent, and various colored LED for each, which cost 10 cent each, the total of the LED. So next I'm going to show you our circuit. This is the standard Node MCU ESP32 that we use for this project, and this is all the connection when we put it on the breadboard. So as you can see, the Node MCU will be connected to the resistor, and how the DC motor with fan were connected using the breadboard. And the actual circuit looks like this, where all the sensors were combined on the breadboard, all the ultrasonic sensor, all the active buzzer, the light dependent resistor, and also the temperature and humidity sensor is connected using the breadboard to make it function.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Nazari bin Abu. I will continue the presentation regarding the coding structure involving Visual Basic and Arduino IDE for controlling, interacting with hardware devices. The combination of these two platforms allows for creating graphic user interface or GUI in Visual Basic, which communicates with the Arduino hardware to control and monitor systems such as our project Smart Home setup. Okay, first of all, let's talk about Arduino IDE. The Arduino IDE is an open source platform commonly used for programming microcontrollers. It uses a simplified version of C++ that makes it easier to write code for embedded systems like sensor and actuators. Using the Arduino IDE, we can write code that control hardware components and upload it directly to an Arduino board. In this case, it enables real-time communication with the Visual Basic interface to control and monitor the connected devices. The code is responsible for sending data to the Visual Basic interface through the serial connection. Arduino uses access its serial communication features to send data like sensor reading to the Visual Basic application. Visual Basic, on the other hand, is a high-level programming language developed by Microsoft. It is known for its ease of use, especially in developing GUI application. It allows users to connect to the Arduino hardware, receive data, and interact with it. In this context, we are using Visual Basic to design a user-friendly interface for interacting with hardware devices. The various buttons like connect, save, and clear text allow users to control and process data from hardware component easily. As you can see in the slide, there are various buttons that we use. The first one is a connect button. This button is used to initiate connection between the Visual Basic application and the Arduino board via the serial port. The second one is the save button. This button allows the user to save data received from Arduino hardware. Data is likely displayed in a rich text box and can be saved to a text file for later use, which is using .txt. The next one is clear button. This button clears the text display in the rich text box. It is useful when the user wants to reset the display area before receiving new data from the Arduino. And then rich text box. This is where the data received from the Arduino is displayed in real time. It continuously updates as the Arduino sends data through the serial port. And then we have a combo box, which in combo box we have baud rate and CB port. For baud rate, this is a drop-down box where the user can select the baud rate. The baud rate that we use in this project is 115/200, and the port is chosen automatically when we connected the project to the computer. From the slide, we can see the coding that been used to generate the program when certain button is clicked from graphical user interface or GUI. As I mentioned earlier, we use the same baud rate as in Arduino IDE program, which is 115/200. How Visual Basic and Arduino interact with each other? First of all, the user need to select the correct port, for example, COM3, COM4, and so on, and also the correct baud rate, which in this case we are using 115/200 in the Visual Basic GUI. And then click the connect button. It will establish the serial connection with the Arduino, and then Arduino will send data over serial connection, which the Visual Basic application captures this data through the serial port 1 data receive event and displayed in RTB receive serial area. After receiving the data, the user can click the save button to store the data into a text file for future reference, which in .txt format. And then the clear button allows the user to clear the text display in the RTB receive serial, which will reset the display area for new incoming data. This system integrates Arduino IDE for low-level hardware control and Visual Basic for creating a user-friendly GUI that interact with hardware. The Visual Basic application manages serial communication with the Arduino and provide options for saving, clearing, and viewing incoming data, making it ideal for monitoring and controlling hardware in real time. That's all from me. Thank you very much.
The screenshot shown highlights the core functionality of our sensor-based smart home system. The application interface is developed using Visual Studio 2022, designed to capture and display real-time data from 3 key sensors: data display, control panel, and data management. This interface simplifies the real-time monitoring and control of environmental data, making it easy to observe sensor reading and manage the system's functionality efficiently. In this video, you'll see how we program the Arduino system to control a fan based on temperature readings. Specifically, the system is designed to activate the fan when the temperature reaches 30 degrees Celsius. Once the sensor detects that the environment hits this threshold, the fan automatically switches on. If the temperature drops below 30 degrees, the fan will stop running, ensuring energy efficiency and maintaining optimal temperature control. This setup showcases how automation can simplify everyday tasks, providing a responsive system that adjusts to environmental conditions in real time. In these demonstrations, the Arduino program is designed to activate a buzzer when an object is detected within range 12 centimeters or closer. Using an ultrasonic sensor, the system continuously monitors the distance of nearby objects. When something comes within the set range, the buzzer automatically switches on to give an alert. Once the object object moves beyond 12 centimeters, the buzzer stops. This type of setup has practical applications, such as in an automatic door system that opens whenever an object or person is detected within a specific range. It is simple yet effective way to enhance automation and improve everyday convenience. In this video, the Arduino program is configured to respond to change in light intensity using an LDR sensor. The system is programmed to activate a blue LED when the ambient light level drops to 10 or lower. The sensor detects a low light environment. The blue LED automatically switches on. If the ambient light level increases above 10, the LED turns off. This setup can be applied to various lighting control systems, such as automatic night lights or energy-saving applications, where the system reacts to changing environmental conditions. To wrap up, our project successfully demonstrates the integrations of multiple sensors, LDR, HDT11, and ultrasonic, into a cohesive smart home system. We use Visual Basic for the user interface and Arduino IDE to manage sensor data and automations. This project showcases the potential for real-time monitoring, efficient automation, and easy user interactions, which are key features for any smart home system. However, while the system works well, we also identify areas for future improvement, particularly in refining sensor accuracy and expanding the scope for more advanced automation features. In summary, this project has not only proven the feasibility of this system, but also opened the door for further innovations in home automation. We hope this serves as a solid foundation for future development. Thank you.